Good day everyone, we are down to the last method in evaluating capital investment projects under the second classification, which is discounted cash flow method. Now let me open to you the topic, internal rate of return under the discounted method. By the way, I'm Vanessa Bahas, your last reporter from Group 4. Methods that consider the time value of money, or the discounted method. Actually, we're done with the first three methods such as net present value, profitability index or present value index, present value payback, and in this topic, we will talk about another technique of capital budgeting, that is internal rate of return. For the topic outline, number 1 is the introduction to internal rate of return. Second, the purpose of discounted cash flow rate of return. Third one, guidelines in determining the time-adjusted rate of return. And lastly, sample illustration of sophisticated rate of return. Before we move to the sample illustrations of problems, let us first know the meaning of IRR. And IRR stands for internal rate of return. When we say IRR, it is nothing but just a percentage. Yes, it is a rate. From the term itself, internal rate of return. Actually, it is a discounted cash flow technique which takes into account the time value of money. And it says here that IRR, or the internal rate of return, is the rate of return that equates the present value of cash inflows to present value of cash outflows. In other words, when the internal rate of return is used as the discount rate, the present value of cash inflows will be equal to the present value of cash outflows. So basically, the sum of discounted cash inflows is equal to the sum of the discounted cash outflows. That is why the resulting net present value is equal to 0. Now, what does this mean? If the present value is equal to 0, that means the present value of cash inflows is equal to the expected initial cash outflows, which means equal inflows and outflows, wherein you have covered the cost. Yes, we have the break-even cost. Again, kapag ang hinahanap sa problem ay internal rate of return, dapat ang present value of cash inflows natin ay equal sa initial cash outflows. As a result, the rate where the present value is 0. And I hope na naiintindihan po natin. Actually, ang internal rate of return is also known as discounted cash flow rate of return, or time-adjusted rate of return, or sophisticated rate of return. But for the purpose of this discussion, we will focus to the term internal rate of return, or abbreviated as IRR. Now let's move on to the purpose of internal rate of return. Now we have here, number 1, the performance measurement for investments and projects, and 2, it indicates the project's potential for profitability. So basically, it helps the decision makers to decide if they will be able to accept or reject the project. Now we have here, internal rate of return acceptance rule. IRR acceptance rule is very simple. Actually, you can easily understand this. If the internal rate of return is greater than the cost of capital, then accept the project. On the other hand, if the internal rate of return is lower than the cost of capital, then reject the project. Simple as that. And here the time value of money is considered because here what do? We use discounting rate. Of course, time value of money is taken into account. So we have here, for example, the computed internal rate of return is equal to 15%, which is greater than to 10% cost of capital. Ibig sabihin, kapag greater ang IRR than cost of capital, we need to accept the project. Unlike kapag ang computed internal rate of return is only 10%, which is less than 15% cost of capital, ibig sabihin, we need to reject the project. Actually, we have also here 2 procedures of computing IRR. The first one is when the cash inflows are uniform for all the years. For example, 10,000 cash inflows for the first year, and then again 10,000 for the second year, third year, fourth year, and so on and so forth. And for number 2, when the cash inflows are not uniform, which means, kunwari sa first year we have 10,000 cash inflows, Next year, we have 20,000, 30,000, 40,000, and so on and so forth. And in this case, we will follow trial and error procedure. Now let's move on to the guidelines in determining the time-adjusted rate of return uniform inflows. Number one is to calculate the present value factor. And what is the formula to get the present value factor? We have here PVF is equal to net cost of investment over net cash inflows. And the next one, use the present value annuity table to find the corresponding rate and calculate the IRR using the formula. And we have here the formula to find the internal rate of return under uniform inflows. We have here internal rate of return, or IRR, is equal to lower rate plus bracket open parenthesis higher rate minus lower rate close parenthesis multiplied to present value factor lower rate minus present value factor discounted cash flow rate of return over present value factor lower rate minus present value factor higher rate. So, nandito yung legend natin sa right part, wherein ang LR stands for lower rate, HR, higher rate. PVF is equal to present value factor. PVF LR is equal to present value factor for the lower rate. PVF HR is equal to present value factor for the higher rate, and PVF DCF RR is present value for the discounted cash flow rate of return. So for our sample illustration, let's do this. Alberto is considering to buy a new equipment that will cost 350,000 pesos. The new equipment is expected to increase annual net after-tax cash receipts by 120,000 in each of the next 5 years of its economic life. No salvage value is expected at the end of 5 years. Alberto's cost of capital is 20%. And we have here the requirement, compute for the internal rate of return. So from the illustration or from the sample problem, we have here present value of cash inflows, which is 120,000, multiplied to the rate, which is 2.99. And we have here the total cash inflows, which is 358,800, less the cost of investment, which is given 350,000. Now we get the net present value of 8,800. For the cost of capital, we have 20%, and economic life is 5 years. The discount rate used in this example is the firm's cost of capital, which is 20%. And obviously, this is not the internal rate of return. When 20% was used, the net present value is not equal to 0, or the present value of cash inflows is not equal to the present value of cash outflows, or the cost of investment. What then is the internal rate of return of this project? Now let's recall that if the internal rate of return is used as a discount rate, the present value of cash inflows will be equal to the cost of investment. So let us try to solve this problem. So for the solution, let's calculate the present value factor, wherein the formula is present value factor is equal to net cost of investment over net cash inflows. So, lagay lang natin 350,000 for the net cost of investment divided by 120,000 net cash inflows. And we could get the PVF of 2.917. Second step, use the present value annuity table to find the corresponding rate and calculate the IRR using the formula. In our example, the present value factor of 2.917 is on the line between 2.864. The present value for 22% and 2.991. The present value for 20%. So, paano ba natin nakuha yung PVF na 2.991? Actually, ginamit natin tong formulang to. 1 minus 1 over 1 plus R raised to N over R. Then, substitute natin yung values. Unahin muna natin yung 20%. So, 1 minus 1 over 1 plus 20% raised to N. Ano ang N natin? We have 5 years. Then, that's why 5 ang equivalent ng ating N over 20%. And we could get 2.991. And for the value of 22%, we also need to use that formula. And substitute lang natin and we could get 2.864. So for the solution, internal rate of return is equal to LR plus HR minus LR times PVF LR minus PVF DCF IRR over PVFLR minus PVFHR. So, substitute lang natin yung mga values dito. So, IRR is equal to 20% plus bracket, open parenthesis, 22% minus 20% times 2.991 minus 2.917 over 2.991 minus 2.864. And we have here 20% plus 2% times 0.74 over 0.127. And the internal rate of return is 20% plus 1.165. And then add lang natin. IRR is equal to 21.165%. Now let's move on to the guidelines in determining the time-adjusted rate of return, not uniform inflows. So the first one is calculate two net present values for the project at two different costs of capital. The second step is to use the following formula to find the IRR. So what's the formula to find the internal rate of return? We have IRR is equal to LR bracket open parenthesis HR minus LR multiplied to NPV LR minus 0 over NPV LR minus NPV HR closing bracket, wherein LR stands for lower rate, HR higher rate, NPV-LR or the net present value when the cash inflow is discounted at lower rate, NPV-HR the net present value when the cash flow is discounted at higher rate, and 0 represents NPV when the cash inflows are discounted at DCFRR or the discounted cash flow rate of return. Assume that we have a project, and to calculate the net present value, assume that we have negative net present value. Now, calculate the net present value with lower rate, and we will get positive net present value. On the other hand, if we have positive net present value, then we need to calculate the NPV with higher rate so that we could come up with negative net present value. Why do we need to calculate the IRR? Of course, we need to calculate it, and we have to interpolate two NPVs, as I've said, and one must be positive and the other must be negative. Negative NPV and positive NPV, we will try to calculate the rate at which the net present value is equal to 0. So, ang pinaka-goal natin talaga is to get the net present value which is equal to 0. Now, we need to use the formula to solve the IRR. So, in order for us to familiarize the concept, let's have another sample illustration. So, to fully understand the process, let us try to solve this. So, we have here cost of investment, 60,000. Net cash inflows, we have first year, second year, and third year, which is equal to 30,000, 25,000, 20,000. And the cost of capital is 10%. As you can see, compared dun sa nauna nating sample problem, we have not uniform cash inflows. Unlike kanina, pare-parehas yung cash inflows. And now for the requirement, let's compute for the internal rate of return and evaluate the capital investment projects using IRR method. So as we can notice, the inflows are not similar with each other, so the calculation of IRR is a bit complicated, right? That's why we need to use the trial and error method. If we will use the given rate and try to find the net present value, actually it may not be equal to 0. So if we compute the net present value using the cost of capital as the discount rate, the result would be like this. So we have here first year 30,000 multiplied to present value at 10%, which is 0.909. So how we come up with this value? Of course, we substitute the factor in the formula 1 minus 1 plus r raised to n. So we have here 1 minus 1 divided by 1.10 raised to 1, which is first year. Kaya 1 yung n natin. So we come up with 0.909. And the present value of cash inflows is equal to 27,270. So apply lang natin yung formula sa next na year, we have 25,000. Multiplied natin sa 0.826, we could get 20,650. And also for the third year, 20,000 times 0.71, we have 15,020. Based on the computation, the cost of capital of 10% is not the discounted cash flow rate of return or the IRR, because when the 10% is used to discount the cash flows, the net present value is not zero. And our objective now is to find the rate which, when used to discount the cash flows, will be yield the net present value that is equal to zero. In other words, we have to try a rate which, when used to discount the cash inflows, the total present value of cash outflows will be equal to the cost of investment, which is 60,000. In our first trial, using 10%, the total present value of cash inflows is 62,940. Less natin yung cost of investment, which is given na 60,000, and the net present value is 2,940. So far, our objective is to make 62,940 lower down to 60,000 para maging equal ang cost natin sa ating inflows. To do this, the cash inflows must be multiplied by the lower present value factors. So if we look at the table, we can observe that higher rate gives lower factors. In this particular case, we need to have a higher percentage which is higher than 10%. So let us try 12%. Again, ipa-plot lang natin ulit yung table like this. And we have the year, cash inflows, present value at 12, present value of cash inflows. So again, we have cash inflows, 30,000, 25,000, and 20,000 for the third year. Then, complete lang natin yung present value ng 12%, which is 0.893 for the first year. Second year, we have 0.797. And third year, we have 0.712. Then, gawin lang natin ulit yung process. I-multiply natin yung cash inflows to the present value factors. Then, we could get 26,790, 19,925, and 14,240. Then, total lang natin yung present value of cash inflows, which is equal to 60,955. Then, last natin yung cost of investment, which is 60,000. Then, we could get the net present value of 955. We could notice that when we use 12% as a discount rate, the result is positive net present value of 955. So, we have to decrease the total present value of cash inflows, and this can be done by using a higher rate with lower factors. So, always remember na ang target natin ay maging 0 ang net present value natin. So, next slide. Let's try 14%. So, again, kunin lang natin yung present value factor ng 14%. We have 0.877, 0.769, and 0.675. Then, multiply natin sa cash inflows per year. We have 26,310 for the first year. Second year, we have 19,225. And the third year, we have 13,500. Then, just get the sum of each cash inflows. Then, we could get the total present value of 59,035. Then, deduct natin the cost of investment, which is 60,000. And we end up with the net present value of negative 965. We missed our target. Perhaps we use a higher rate. And because the result is negative net present value, at this point, we can stop trying another discount rate. So, if we consider again our previous computation, the discount rate of 12% yield a positive net present value, while the discount rate of 14% yield a negative present value. And our target is 0 net present value, right? So, definitely, the IRR is between the positive and negative net present value that was obtained or calculated. So, the discounted cash flow rate of return, or the IRR, is therefore between 12% and 14%. So, let us summarize these points. So, we have here the solution. Internal rate of return, or IRR, is equal to LR plus HR minus LR multiplied to NPV LR minus 0 over NPV LR minus NPV HR. So, substitute lang natin yung values katulad nung ginawa natin kanina sa previous illustration. So, we have here IRR 12% plus 14% minus 12% times 955 minus 0 over 955 plus 965. So far, baka magtanong kayo or magtaka kayo bakit plus na yung naging formula dito or naging equation dito. Bakit addition na? So far, when we deduct negative values, we should use the positive sign or the addition. So far, kaya naging 955 plus 965. So, let's continue. The IRR is equal to 12% plus 2%, which is galing siya sa 14% minus 12%, which is 2%, times 955 over 1,920. Kasi pinag-add natin yung values ng 955 plus 965. So, the IRR is 12% plus 0.995. And we have here the final answer. Internal rate of return is equal to 12.995%. In evaluating capital investment projects using the IRR method, the IRR is compared with the minimum desired rate of return or the cost of capital. So, in this project, IRR is higher than the cost of capital. That's why we need to accept the project. So, as we can notice, IRR of 12.995% is greater than 10% of cost of capital. That's why the decision that we should follow is to accept the project. So for our final thoughts, I will give you a recap of all the important concepts and terms in my presentation. So 4 methods that considers the time value of money. We have net present value index, present value payback, and the topic that was previously discussed is the calculation of internal rate of return. Now, again, what is internal rate of return? When we say internal rate of return, it is the same terms such as discounted cash flow rate of return, time-adjusted rate of return, and sophisticated rate of return. Actually, it is a rate wherein the net present value is equal to 0 and the present value of cash inflows is equal to the present value of cash outflows. This method is used to determine the project if it is acceptable or not by comparing the computed internal rate of return to the cost of capital. So, we also have 2 procedures in calculating the IRR. So, the first one we have when the cash inflows are uniform for all the type of the years. And the second one is when the cash inflows are not uniform. In that case, we will follow the trial and error method or the interpolation procedure. So, the last one is for the formulas that we need to remember. For the uniform inflows, we have internal rate of return is equal to lower rate plus higher rate minus lower rate multiplied to present value factor of lower rate minus present value factor of discounted cash flow rate of return over present value of lower rate minus present value factor of higher rate. And for the not uniform inflows, we have IRR is equal to lower rate plus higher rate minus lower rate multiplied to net present value lower rate minus 0 over net present value lower rate minus net present value higher rate. Well, I guess that would be all for my part. And if we have questions, please don't hesitate to message me via Messenger. Vanessa Kibuyin Bahas. And before I end up this discussion, I just want you to know that our group prepared 30 theories and 30 sample problems for you to review in order to familiarize the concepts of capital budgeting. Actually, all of our presentations were already uploaded in the Google Drive, so you can now access them. Always do your best. What you plant now will harvest later. And we hope that you've learned a lot from our group. Thank you for your attention. Just in case you have clarifications, don't hesitate to reach out us. Once again, we are the Group 4 with the topic Capital Budgeting. Again, I'm Vanessa Bahas, and here are my group mates. Biag Genesis de Guzman, John Miles, De La Cruz Alina, Yang Stephen, Nova Cristel, Ortega Kimberly Tagalog Dave, and Vincent Ero. Thank you so much. Have a blessed Tuesday morning.